Today we're on lesson 101, and it's on 3 by 3 determinants. And we used Kramer's rule to solve a system of equations with x's and y's. And remember, I told you it was super simple. I think most of you enjoyed doing it. And so today we're going to cover how to use it for a system with 3 variables. All right, so if you look on page 576, example 101.1, the system is 2x plus y plus 2z is equal to 7, and x plus y minus z is equal to negative 2. 3x minus y plus 2z is equal to 16, and it's asking us to solve for x, y, and z using Kramer's rule. All right, so the denominator of the solution is always going to be the same, whether it's x, y, or z, and it's always going to be this part right here. So that matrix in the denominator will be 2, 1, 3, 1, 1, negative 1, 2, negative 1, 2. Now the problem is that in order to evaluate that matrix, we can't just do down the hill minus up the hill, because some of the numbers don't run in, there'll be a blank. So what we have to do is we have to copy the first 2 lines over again, the first 2 columns. So that'll be 2, 1, 3, 1, 1, negative 1. All right? So now if you draw the lines, it will be down the hill. Did I do that right? Yes. Down the hill, and then minus all of the up the hills. Okay, so when we do that, what are we going to get? Down the hill will be 2 times 1 times 2 is 4. And then 1 times negative 1 times 3 will be minus 3. 2 times 1 times negative 1 is minus 2. Minus up the hill would be 3 times 1 times 2 is 6. Negative 1, 2 would be 2. And 2, 1, 1 is plus another 2. Sorry, I got kind of close there. All right, so that'll be the denominator. The numerator, just like it was with Kramer's rule for its system of x and y, when we solve for x, we take the constants, these, and we substitute them in for x. So instead of writing these numbers, we're going to write these numbers. So this will be 7, negative 2, 16, and then 1, 1, negative 1, 2, negative 1, 2. And then like we did for this one down here, you have to copy the first 2 columns again. So 7, negative 2, 16, 1, 1, negative 1. All right, so then it's the same process. It's down the hill minus up the hill. Okay. So that will be 7 times 1 times 2 is 14. 1 times negative 1 times 16 would be minus 16. 2 times negative 2 times negative 1 would be plus 4. Then minus up the hill. 16 times 2, negative negative 7. And 2 times negative 2 times 1 is minus 4. So let's see what we get here. So x will be equal to 14 minus 16 is negative 2 plus 4 is 6. Minus 32 plus 7 is 39, minus 4 is 35. If I did that right. 14 minus 16 plus 4. 32 plus 7 is 39. Minus 4 is 35. Okay. And then in the denominator, 4 minus 3 is 1, minus 2 is minus 1, minus 6 plus 2 is 8 plus 2 is 10. So 6 minus 35 would be, how did I, 32 plus 7 is 39 minus 4 is 35. 35. Negative. Oh, this is negative 2 plus 4. Oh, that's where it's wrong. Sorry. 14 minus 16 is negative 2 plus 4 is 2. So this will be minus 33 over minus 11, which is 3. Now, the denominator is negative 11, so we don't have to calculate that again. When we go to calculate y, the denominator is already going to be negative 11, so just put it in. And the matrix then, the x's will stay the same, 2, 1, 3. The y's will now become the constant, which is 7, negative 2, 16. And the z's stay the same, 2, negative 1, 2. Okay, so now we copy the first two columns again. 2, 1, 3. 7, negative 2, 16. Down the hill. Minus up the hill. So down is negative 4, negative 8. And 7, negative 21. Plus 32. Oops. Minus up the hill. Negative 6, negative 12, minus 16, minus 32, plus 14. And that's all over negative 11. So that's minus 29 plus 32 would be 3. And then this will be minus 44 plus 40 would be minus 30, so it would be plus 30. So this is 33 over negative 11, so that's negative 3. And though, we can use Kramer's rule to find z, but it's not really necessary. Once we already have x and y, we can just plug in what we have into either one of, or any one of those equations. So I'm just going to say x plus y minus z is equal to negative 2. That's the middle equation. And plug in the 3 that we got for x and the negative 3 we got for y, and then we'll solve for z. So z will be equal to positive 2. So as an ordered triplet, it would be 3, negative 3, comma 2. All right, so let's try another one of these. This next one, it only asks us to solve for z. Okay, so we only have to find one answer. The system is 3x plus 2y plus z equals 9. And 2y plus 3z equals 14. And x plus 2y equals 3. All right, so anytime there's a variable that's missing, remember we're going to put a 0 in that spot. So when we fill in the matrix, we have the full matrix. So we're solving for z this time. So the denominator, remember, is this right here. So that would be 3, 0, 1, 2, 2, 2, 1, 3, 0. And I'm just going to write the first two columns again. All right, so we're going to get 0 plus 6 plus 0 minus 2, 6 times 3 is plus 18 plus 0 for the denominator. Okay, in the numerator, we're solving for z, so we're going to take these and replace the z column. So this will be 3, 0, 1, 2, 2, 2, 9, 14, 3, 3, 0, 1, 2, 2, 2. Down the hill minus up the hill. Okay, so down will be 6 times 3 is 18 plus 28 plus 0 minus 18. Let's see, that would be 28 times 3 is 84, and it's positive. And then plus 0. So z will be equal to 46 minus, let's see, 4 and 8 is 12, 102 over 6 minus, is that a plus 18? Did I miss a negative somewhere? No. $18. 2 plus 18 is 20, okay. All right, so then 12 minus 6 is 6. 9 minus 4 is 5. That's negative 56 over negative 14, which is equal to a positive 4. So you have to be really careful and meticulous about drawing the lines and making sure that you're multiplying the right numbers, but it's a lot faster than having to use elimination or substitution 2 different ways here to solve this system. Now let's just say, for example, if you come up with an answer that's something like this, 0 over 20, what's the answer to that? It's 0, isn't it? And then you move along and you find your y and your z. If you came up with an answer that said x equals 20 over 0, what would be the answer? You can't divide by 0. So if you end up with that, you're going to write no solution. So 0 in the numerator is fine, but 0 in the denominator gives you a no solution.